Your Tenma experience begins with MCM Electronics, one of the largest catalog distributors of consumer electronic parts and accessories in the United States. Our knowledgeable and friendly sales staff enters your order immediately, with 99% of all orders shipped within 24 hours. All of MCM's more than 20,000 products are stocked and available to ship immediately from our modern and efficient distribution facilities in Dayton, Ohio, or Reno, Nevada. We provide a toll-free 1-800-TECH line for applications assistance before and after your purchase. We further support all products with our factory service center, where both warranty and out-of-warranty service is performed. Time can be a problem or your friend. You can make time your partner at MCM when you purchase Tenma test equipment using the Tenma Purchase Plan. The new Tenma Purchase Plan will allow you to purchase Tenma test equipment and selected items today and pay tomorrow. MCM provides the total package of consumer electronic parts, superior customer service, and a variety of convenient payment terms and delivery options. So, let MCM Electronics be your single source for generic or name brand audio and video parts, computer components, original Pacific Rim semiconductors, Tenma, and other name brand test equipment. Discover the MCM experience, where we value your business and provide superior customer service to keep it.
Hello and welcome to Microwave Oven Repair. Current statistics show that 85% of American homes have microwaves, and as with any electromechanical device, sooner or later they're going to encounter a service problem. Microwave oven repair is truly a strong and upcoming service industry. In this presentation, we'll present practical and easy to understand service methods for most current microwave models. Repairing common microwave problems is actually quite simple, as you will soon see, and we can do most of the repairs with common hand tools, such as screwdrivers and pliers. The only test equipment needed will be an inexpensive volt-ohm meter, or if you prefer to spend a little more, a sophisticated device designed specifically for microwave oven troubleshooting. We will demonstrate both in the video and let you make the choice. It's also a wise idea to invest into a microwave leakage detector. Let's now have a look at the topics we'll be covering. First and foremost, we will discuss safety procedures. If there is any part of this presentation that you watch closely, make it this one. Voltages in excess of 3,000 can be present inside the oven even if the unit is unplugged, so pay very, very close attention. Microwave ovens can be safe to service if and only if you follow the proper safety procedures. Next, we will discuss some basic microwave oven theory of operation. This will help the servicer to understand exactly how an oven operates and thus have a better practical comprehension of which direction to take when troubleshooting a problem. After that, we'll approach cover removal and parts identification inside. We will highlight all of the critical and common failure components inside the oven and describe their function as it relates to operation. In the next portion of the presentation, we will present several microwave oven problems and display the most common repair procedure to correct them. The last part of our presentation will concern proper reassembly, testing, and leakage detection. Let's now go ahead and have a look at some safety procedures and practices. Before removing the cover, it is essential that the power be removed. Always unplug the oven prior to servicing. When the oven is plugged in, make sure that you use a properly grounded outlet. After the cover is off, you must first locate the high voltage capacitor. All ovens will contain one, and it should look similar to this one. Do not touch anything inside the microwave until you have discharged this capacitor. It can be discharged by shorting across its two terminals with an insulated handle screwdriver. Each and every time the oven has been energized, you must discharge this capacitor after turning it off. Failure to discharge the cap can result in severe electrical shock. Be careful when you are close to the high voltage transformer. The primary side will contain 110 volts, and the secondary can contain several thousand. When the magnetron is operating, be careful of high voltages and do not place any metal tool near it, as the magnetron can jerk them right out of your hands. Do not try to bypass or defeat the door interlock switches and operate the oven with the door open. This can damage the oven and expose you to high microwave energy. When reassembling the oven, make certain there are no extra parts. All screws should be properly replaced and a leakage detection performed. Let's now have a look at some basic microwave oven theory of operation. This diagram will show you, in a broad sense, the basics. The microwave has several protection circuits which are designed to provide safety to the user and protection to the oven itself. These include fuses, both standard and thermal, interlock switches on the door, and a thermostat. Any one of these items can shut down the cooking operation in the event of a problem. Next, we have the control circuit. The control circuit typically consists of a printed circuit board mounted behind the touchpad on the front of the oven. The control board contains a microprocessor, which controls the display, buzzer, power supply to the high voltage section, temperature control, and several other items. A small low voltage DC transformer provides power to most control boards, and some control boards actually have this mounted on them. On older microwaves, you'll find mechanical assemblies which regulate the cooking time and a limited amount of other options. In this presentation, we'll be using only more current models, which have electronic control boards. Let's now move on to the high voltage section. This section includes the high voltage transformer, which steps up the input 120 volts to approximately 2,500 volts AC. This voltage is then applied to the voltage doubling circuit, which includes the high voltage oil-filled capacitor. The capacitor will charge to approximately 4,000 peak volts. Attached to the capacitor, you'll find a diode or a rectifier, which changes alternating AC current to pulsating direct current. Across the terminals of the HV capacitor, you may find a resistor. The typical value is around 10 megohms and helps discharge the HV capacitors after shutdown. Regardless of the fact that the oven may have one, always discharge the capacitor yourself. The magnetron receives the voltages from the high voltage circuit. The magnetron is actually a large vacuum tube. Electrons flow from a heated cathode to an anode surrounded by a magnetic field. The oscillator operates at a very high frequency. Most microwaves today use 2,450 megahertz of RF energy. The upper tip of the magnetron is called the antenna. The RF energy is emitted from the antenna and reflected through a waveguide assembly. The waveguide channels the RF energy from the magnetron towards the oven cavity. Before entering the oven cavity, the RF passes through a stirrer, which is a metal fan operating at a very low RPM. The stirrer deflects the RF in the oven cavity to promote even cooking. Some microwaves use a turntable to rotate the food instead. There is also a stirrer cover at the top of the oven cavity to protect it from food splatters. The RF finally ends up in the oven cavity. The cavity is surrounded by metal sides and will remain cool during cooking. Any warmth observed is typically a result of heat transfer from the food itself. The front door is metal and contains small holes to allow you to see in. The microwaves will not pass through as the wavelength of the RF is larger than the holes. Let's now move on to cover removal. First, unplug the unit from the power source. Remove any glass trays and shells from inside the cavity. If your microwave has a turntable, remove the coupling and put it to the side. Looking at the rear of the unit, you'll typically find a series of screws around the edges of the cover. Remove them and be sure not to misplace any of the screws. Now tilt the oven on its back. You'll probably find more screws on the bottom. And there's also 3 more on the opposite side. On the top of this Tappan model, there are 2 plastic plugs that must be removed. When it appears that all screws and fasteners have been removed, slide the cover to the rear and pull up on the bottom edges. We're now going to identify some of the critical components inside. You are looking at a view of the right side. Let's zoom in for a closer look. We're now looking at the high voltage transformer. The transformer is removed easily by unscrewing the 4 bolts which hold it into place from the bottom. All wires can be detached by simply pulling off the spade connectors from each terminal. To the right of the transformer is the high voltage capacitor. The capacitor is held into place by a band and 2 screws that can be removed from the bottom. In front of the cap is the rectifying diode. Notice one lead is going to chassis ground and the other attaches to the capacitor and is easily removed. Directly above the capacitor is the cooling fan. The operation of this fan is essential to maintain proper temperature of the magnetron and HV transformer, which can get extremely hot. Most fans operate on 120 volts. Above the transformer, we'll find the magnetron. It is fairly simple to remove. On this model, we'll unplug the filament wires, and then moving to the top of the oven, you'll see 4 nuts which support the magnetron and hold it to the waveguide assembly. 2 are here, and the other 2 are here. Remove these 4 nuts while supporting the magnetron on the bottom. We're now looking at one of the safety door interlock switches. When the door of the microwave is open, the switches prevent the microwave from operating. The door is now open and closed. Once again, open and closed. These switches take a lot of abuse and are a common cause of a microwave's failure to perform. On the top of the oven, you'll find an ABC type fuse, which is directly in line with the AC input. To replace it, use a fuse puller or pry it out with a small screwdriver. Next in line with the ABC fuse, you'll find a thermal fuse, or temperature fuse. This is typically mounted in the oven cavity exhaust vent on the rear of the unit. Typically, if one exists, you'll see two wires on the top entering the vent. To test or remove the fuse, remove the screws that hold the vent cover into place. And unclip it. To remove the fuse, simply slide back the protective sleeve, clip it off, and solder in a new one. And be sure to heat sink. Let's now have a look at problem number 1. The oven is completely dead. There are no functions whatsoever. First, check the ABC fuse to see if it's open. You can test it with any standard VOM. Next, move on to the thermal fuse and see if it is open. Once again, using a VOM to check the circuit. It's possible it could be a defective interlock switch. Be sure to remove the switches out of circuit before testing them with a VOM. Check for a broken door latch spring. Observe the door opening and closings, and place a meter on the switch while you're doing it. The control board could be defective. Check and replace the board if there is in fact low voltage AC coming from the low voltage transformer. Problem number 2. The microwave has a very slow cooking time. The most likely problem is a defective magnetron. Let's look at some tests we can do. If your magnetron is out of circuit, connect a multimeter, put it on resistance, and check the two input terminals. The meter should read between 0 and 1 ohms. If it reads higher, chances are you could have a leaky magnetron. Now check both inputs with reference to ground. The meter should always read 0 ohms, no continuity whatsoever. And now check the other side. Let's now test the voltages with the magnetron installed. We want to make certain that the proper voltage is reaching the magnetron, so let's test the entire high voltage circuit. To do this, you'll need a VOM capable of measuring up to 4,000 or 5,000 volts. We'll be using a device called a microanalyzer, which is capable of measuring up to 5 kilovolts AC or DC. Let's first test the input or primary side of the high voltage transformer for AC line voltage. To do this, the oven will have to be fired up. Place a plastic or paper cup of water inside the oven cavity. Connect your test leads, turn it on, and stand back. As you can see, we have around 109 or 110 volts, which is acceptable. Don't forget, after every time you fired up the oven, you must discharge the high voltage cap. Now let's check the secondary side for high AC voltage. Connect your probes to the closest point you can. You should read between 2.5 and 3 kilovolts. We'll check for high DC voltage by connecting our black lead to chassis ground and our red lead to the side of the capacitor which attaches to the diode. When we turn the oven on, we should observe an initial voltage of 3 to 4 kilovolts. and as the magnetron starts to draw, the voltage should stabilize at around 2 to 2.5 kilovolts. If the voltages are present, you probably have a defective magnetron. You could also have a bad diode in the high voltage circuit. Test and replace the diode with any common multimeter. You may find a defective triac module. They're used in various microwave ovens in place of a power relay. Typically, the triac module is controlled by the electronic control circuit. A defective triac may prevent the oven from going into the cooking cycle or cooking slow. To accurately test the triac, it should be out of circuit. We'll test ours with the microanalyzer. Connect the red lead to MT2, yellow to the gate, and black to MT1. When the test button is pushed, both LEDs should light. The next likely cause of slow cooking time would be a defective thermostat. And last, check your AC line voltage. Most wall outlets read between 110 and 120 volts AC. Our next problem concerns intermittent oven operation. Typically, this is caused by an intermittent interlock switch. Test all the switches with a VOM. You may have bad connections in the high voltage circuit. Check all wires and connectors for good crimping. Check your magnetron tube. It could also be defective. You might have an intermittent control board. If this is the case, you must replace the entire board. Your oven door could be out of alignment. Adjust the door to ensure good interlock operation and check the door seal thoroughly. Problem number 4 is quite common. A loud popping noise was heard from the oven and then it stopped. Chances are high that the capacitor is leaky or shorted. Test the capacitor with a capacitance checker and replace it if necessary. Also, check the rectifying diode. It could be leaky or shorted. Problem number 5 addresses noisy oven operation. You could have a noisy fan or vibrating sound coming from the oven. Lubricate, adjust, and check the mounting of the cooling fan. If a loud buzzing noise is present, see if it's coming from the HV transformer. If so, replace it, even if it's putting out voltage. A loud noise could be observed coming from the turntable. To locate the turntable motor, turn the unit on its face. This particular model uses only 2 screws to secure the cover, one here and one here. It clips into this side. We can now see the turntable motor. Lubricate or replace it as necessary. You may hear a slow clicking sound. If so, check the stir for grease collection and for proper mounting, especially if the microwave has been moved. Problem number 6. The oven goes dead when the door is closed. First of all, check your main fuse. Next, determine if it's a bad interlock switch and replace if necessary. It could be the low voltage transformer. Test for 120 on the primary side of the transformer, and the voltages on the secondary side can be confirmed by your service manual. Once again, you could have a bad triac. Test and replace if necessary. Problem number 7. The oven keeps blowing the fuse. More than likely, you have a bad interlock switch. Test and replace as necessary. You could have a leaky high voltage rectifying diode. Once again, test and replace if necessary. Your magnetron could be shorted. Test the input to the magnetron for no more than 1 ohm. You could have a defective door latch assembly. Check the operation of all latches on the door. Problem number 8. All oven functions seem to be operating normally, but there is no cooking. You probably have a shorted or leaky magnetron. Once again, test the inputs for 0 to 1 ohm. Also, test each input to the case of the magnetron. There should be infinite resistance. You may have a shorted high voltage capacitor. Test it, and if there is any resistance present, replace it. A defective triac can cause this problem as well. If the oven contains one, test and replace if necessary. Check your rectifying diode. It could be leaky or open. If the magnetron contains a thermal cutout, test it with an ohm meter. If it shows open, replace it. When reassembling the oven, make sure of the following. Check all electrical connections, making certain none of them come in contact with the case. Remember, you are dealing with lethal voltages. If you had to move or relocate any protective shields, put them back properly. If you removed or replaced the magnetron, make certain that you replace the RF gasket around the antenna. Before replacing the cover, clean out the inside thoroughly of any food materials, especially grease, which is, of course, flammable. Also, check all vents for blockage and food collection. Make sure that there are no extra parts or screws left over. This could cause a malfunction or allow excessive microwave energy to be emitted. When your repairs are complete, it is highly recommended that you do a leakage test. The test will ensure that any unacceptable level of microwaves is not being emitted. Several survey instruments are available by different companies. We have chosen this Holiday model HI-1801 at random. Microwave radiation leaks should be made around the front door and gap areas. It's not a bad idea to test the rear vents as well. Before starting the test, place a breaker of prescribed amount of water in the cavity. Make sure that the power is on high. Set the timer for about 3 or 4 minutes. Hold the wand by the insulated part of the handle, in this case, the red part. Start the oven and hold the tip perpendicular to the surface that you are testing. Your reading should not measure any higher than 4 to 5 milliwatts per square centimeter. On most new microwaves, you might not get any deflection at all. If you have replaced the magnetron with the cover off, check the seal where it attaches to the waveguide for leakage as well. That's going to wrap up this session of microwave oven repair. Thank you for joining us.